Triangle day ended minutes ago, and we're going to preview Monday's reaction. It's our most important mechanism because it's the biggest one all semester. So we're going to do kind of an intro version here, and then on Monday, I'll give you lots of tips about how to learn this. So borane is here, but I'm not reacting borane. What I do on tests is I do it this way. What's happened is borane already reacted twice to make this. And you're going to show me the third time. And the reason we do it this way is I don't want you doing the same mechanism 3 times. Okay? And do you remember which atom the pi electrons has attacked all day today and the previous day? Monday. No, don't give me a name of an atom. It's always, you have 2 atoms to choose from. Why did you pick the particular one you chose? Because it always was not hydrogen. I should have said it was not always hydrogen, but the more positive atom. Reminder number 2, 2.1, 2.0, and the subtle distinction's important. Do not attack hydrogen. Hydrogen's got a slightly negative charge. I could write it there if you want, but I'm not going to. Okay, I will, because this is not the official version yet. Do not attack the minus atom. Attack the positive atom. And then B would have 4 bonds, wouldn't it? 2 to R, 1 to H, and 1 to carbon down there. B with 4 bonds we saw earlier. What's its charge? B with 4 bonds, right? It was on our demercuration one, wasn't it? No, it was on there. Where'd you go? Reagent. Yeah, this one. There it is. B with 4 bonds to H. Oh, here it is. What's the charge? -1. So B is going to get a -1 charge. And hydrogen's more electronegative than B. Do you think hydrogen's happy that boron gets to be a minus when hydrogen is actually the more electronegative atom? No. So you know what happens? Hydrogen takes its electrons and says, I'm not going to put up with that. I'm going to go bond to something. I'm going to go bond to the most substituted carbon right now with my electrons because B's getting the friskies, feeling minus. I'm just going to say, no, you're not. I'm taking my electrons. I'm going right next door. Why that carbon? You should be able to tell me why that carbon and not the other one. More substituted, spends more time with a plus charge because of hyperconjugation. I remember hearing that somewhere earlier today, right? Okay. The result of those 2 arrows is this. The bonds happened at the same time. So they have to be on the same face. That's the same side, top or bottom. I'll choose top. Looks like the product has them on top. So when 2 bonds happen at the same time, 2 bonds happened at the same time, gives, same time, gives syn addition. What's that mean? Syn. On same side, exactly. They're on the same side. Syncopation, kind of together in rhythm. Same width. So that's why both are wedges here, right? And what's the other product? 50-50. I'm not going to draw it because I don't need 2 products. But 50% of the time they be from underneath. Dash, dash. Also syn, right? Okay, that's the end of step 1. That's our simplest mechanism of the semester. 2 arrows and draw the product. Step 2 has 6 steps. It's the toughest one of the semester. It's the oxidation part. Hydroboration up here. And I can tell you what R is now, followed by oxidation. Watch this. Tell me what I'm trying to say here. Oh, what he said was this reacted 2 times with an alkene number 1, and then alkene number 2, and then this is alkene number 3 reacting. You're showing me the last one. And you get 3 identical R groups. Do you agree? This is a trialkyl borane. 3 R groups on a boron. Borane was BH3, remember? Oh, it's right. Right? See? Borane. Okay. Oxidation. How we do it? We'll do oxidation. I'll make it a test version. So instead of that, why not? I will. And we'll have in black you're going to get this. And an OH plus HO. There we go. We're going to do that mechanism. And I'm going to have you memorize certain patterns. First thing, you have an O minus there, right? You're tempted to use it first, I hope, because it has a charge. It's a minus. That's going to be more reactive than any other pair of electrons, I hope. And what do you think of when you think of OH minus? Always, almost always. No, OH minus, dude. Hydroxide is not the same as ROH at all. Now, guys, OH minus, you used it in 141 like 25 times. It's a base. So, guys, you hear hoofbeats, you're thinking of horses, right? It's going to be a base. Okay, so what's our best acid here? Take a wild guess. Yeah, the H bonded to the O in hydrogen peroxide. There you go. So can you remember that the first step of the mechanism and the last step are both acid-base? That'll help you. Step 1 and step 6 are both acid-base. Okay. Acid-base. So you created a peroxide anion. And water. You will not be doing anything with the water. Okay. Now this is the first O minus you made, right? You're going to do this twice. Every time you make O minus, every time you make O minus, your next step is to attack the most positive atom on the page. Which atom's the most positive atom on the page? Boron. So the 2 times you make O minus, the first 2 times you attack boron with it. So you made it, you attack boron, and boron's going to have 4 bonds. I'm numbering my steps. Step 1, acid base. Step 2, attack boron. Now B has how many bonds? It's got 2 R groups, it's got a carbon group, and now it has OOH. How many bonds does B have? 4. What's its charge every time it has 4 bonds? Minus. Can you remember, in this mechanism, boron goes from 0 formal charge, watch the pattern here, down to -1. Next step, up to 0, down to -1. You like my pattern so far? Because it ends at 0. And what's my pattern and why do I like it so much? It's my name. It's a W. Okay. So boron, it started 0. It's now minus. Guess what it's going to be after this next step? 0. And after that next step, minus. That's your last minus. And then back to 0. Your charges are done. Okay? With boron charges, they're done. 0, -1, 0, -1, 0. We got a ways to go, don't we? Here's how it gets that way. And tell me what you think this is called. The bond from C to B moves and goes next door to O for 2 reasons. Step 3. What would you call such a thing where something shifts inside the molecule? No, that's just pi electrons shifting. No, when atoms shift, yeah. So this is the other kind of rearrangement you're going to see this semester. First type was carbocations, right? This is the only other type for this semester. And the 2 reasons for it are, this bond must break. Peroxide is an unstable entity. Did they tell you why in Chem 141? They just told you to memorize it, right? Told you to memorize it as an exception for oxidation states. And they may have mentioned it was unstable. That's why we put it on things like cuts and things. But they didn't say why it's unstable. Here's the answer. Soon to disappear. Is it stable when atom with lone pairs is adjacent to an atom with lone pairs? No, it's not. What do you call that? Lone pairs hate each other. Lone pair repulsion is predominant in molecules like peroxides and halogens like iodine, which they also use to disinfect cuts. I2, it's purple. You ever had it put on? Your arm gets cold because there's ethanol in there and it evaporates. That's not why the iodine's not doing that. Okay? Anyway, you've got to break the lone pair repulsions, mission accomplished, and you get rid of the minus charge. Yeah? And put it on a more favorable location. That's a more favorable location for a minus, isn't it? Tell me why. Why is that a better minus than the one on boron? More electronegative. And the other product, careful. I told you what to do with rearrangements earlier. Copy everything except the bond you broke. Because it's hard to visualize them. I agree. This helps you. Copy everything except the bond you broke. Okay? The Br2 was up there on the top right. It's not bonded anymore. It's still bonded to the O. Now, what's that O bonded to? Top right green carbon. This carbon keeps the electrons and bonds to the O next to the B. Do you agree that this gives this? I hope. Yep. OH minus leaves. There it is. Carbon ends up bonded to O instead of B. Carbon ends up bonded to O instead of B. B lost a bond. Hey, B, what charge when you have 3 bonds? As promised, 0. What did you do last time you made an O minus? I told you exactly what to do. Attack the boron. You're doing it again. You made this O minus, what did not exist previously. Attack the B. And that's 4. 4 in purple. Gotta hurry. Not too much. Neat. I'll make it a little neater. And you got an OH on top. Hey, boron, 4 bonds. What's its charge? -1. And tell me, I told you the 6th step was what kind of reaction? Acid base. Doesn't that hint something about this? Base plus acid. No, my apologies. My apologies. I messed up. Just looking for ways to help you, but sometimes, oh, don't ever make that mistake. That was the worst mistake of the century. I wrote this by mistake. Oh no. That is not on this page at all. Yet I see students do it. It's an honest mistake. And it's a great opportunity to remind you, you can't make case mistakes in any chemistry class. Teachers will go ape shit on you. You cannot tell me B, capital R is bromine. Do not. Okay, I'm glad it happened. Okay. Whew. I was going ape shit, wasn't I? Sorry about the swearing. It happens sometimes. So I got that, and I got the conjugate base of the final product right here. I'm just setting up for you. There's the conjugate base. Tell me how to get there and how many arrows for step 5, which goes from here to those 2 guys there. How many arrows? I'd like to point out this OH is really on top over here. Would you be happier if I drew it on top instead? I am not changing the molecule at all. I'm sorry I'm going over time, but there. It's more visually obvious, I think. 1 arrow. Tell me where it starts and where it ends before I answer that question. Where does the 1 arrow start between the O and the B? Clearly, this O is no longer bonded to the B, and then it starts there, and which direction does it go? Towards the O to make an O minus, or towards the B to make a B minus? Which is silly, because O is more electronegative. Don't be silly. Towards O, yeah. So making B negative would be incredibly silly. If you have a choice of making B negative or O negative, it's always O negative. And then what I say the 6th step was? Acid base done. Done. So we'll go through all those shortcuts and all the steps again on Monday. This is the mechanism that is surprisingly done the best overall for the class at the end of the semester, because they know it's coming. It is on your test. It will be on the next one as well. And it will be on the final. Not a maybe. 100% guaranteed. 14 points. Not to be laughed at, right? Yeah. Uh-oh.